Today I am going to start the new chapter, Dimensional Analysis. This chapter is very easy and it's also based on this previous chapter like this, derived units, fundamental units already I have discussed here. So how can we obtain the dimension? So first one, dimensions of a physical quantities. हम किसी भी physical quantity का dimension कैसे लिखते हैं? So what is the method? The dimension of a physical quantity are the powers to which the fundamental units are raised in order to obtain the derived unit of that quantity. इसका मतलब जिस क्वांटिटी का हमको डायमेंशन निकालना हो उस क्वांटिटी को हम देखते हैं कि उसके लिए डिराइव्ड यूनिट्स क्या हैं और उन डिराइव्ड यूनिट के फंडामेंटल यूनिट जो यूज किए गए उसके ऊपर हम पावर को रेज करके और निकालते हैं. जैसे हम लोग कहते हैं एरिया. Area is derived unit, and suppose your aim is to find the dimension of area. So you know area is equal to length into breadth. Length, what notation we will use? L. And for breadth also we will use L. It means L into L becomes, you can write here, L square. So L, length, is a fundamental unit. And what is the power raised on this fundamental unit? 2. So when you will raise the power 2 on this fundamental unit of length, then you will get a derived unit, what here? Area. It means the dimension of this area is taken as L to the power T. And dear student, remember this. In mechanics, to express the length, mass and time, मैकेनिक्स में लेंथ, मास और टाइम को एक्सप्रेस करने के लिए हम यूज करते हैं लेंथ के लिए L इन ब्रैकेट, मास के लिए M एंड टाइम के लिए T. इट मीन्स इन मैकेनिक्स the length, mass and time is denoted by L, M and T. Simply you can say. Similarly, if the length, mass and time is given, so it means you are going to use in the mechanics here. Suppose a physical quantity is A in length, B in mass and C in time. हमने क्या कहा? Suppose कोई physical quantity is given A in length, B in mass and C in time. So how can we write the dimension of that physical quantity? So dimension of that physical quantity is given L. For length, what notation will we use? L. What is the power raised on it? A. L to the power A. B in mass means M to the power B and C in time. So you can write here T to the power C. It means L to the power A, M to the power B, T to the power C is the dimension of that physical quantity which is A in length, B in mass, C in time. But remember this, length is fundamental unit. तो इस फंडामेंटल यूनिट लेंथ पे कितना पावर रेज किया गया? A. इस फंडामेंटल यूनिट पे B, इस पे C. तो सिंपली यू कैन से हियर कि द डायमेंशन ऑफ ए फिजिकल क्वांटिटी are obtained by raising the proper power on fundamental units. Now, dimension formula of the some physical quantity. Here in your book, so many quantities is given. You can go through this one and also you can find out the dimension formula. But some quantity, I am telling you how can you find the dimension formula. As suppose first one, remember this, in the dimension, as already I have told you in mechanics, length is denoted by capital L in bracket in mechanics, mass capital M and time capital T. Other quantities also, because there are 7 fundamental quantities. But in mechanics generally we will use length, mass and time. And for finding the dimension formula on some physical quantity, remember this, for any distance, since length is a distance, so for any length or for any distance, it's not matter that distance is large or small, either meter or kilometer or centimeter, millimeter, it's not matter. For any length, always we will write capital L. For any mass, capital M. For any time, capital T. Either that time is in hour or minute or second, it's not matter. So same way, first one, suppose area. Already I have told you how can you find the dimension of area. So first you will write what is the formula you know for area. You know length into breadth. And you know length, it's a dimension you will write L. Breadth is also a length. Breadth is also what here? A length. So for breadth also you will write what here? L. And when you will multiply here L into L, you will write here L to the power 2. And whole this thing will write in the bracket. It means the dimension of area is how much here? L to the power 2. It can also written as 3 line means it can also be written as in other way, or in your book also given m to the power 0, L to the power 2, t to the power 0. But it not necessary always you write down here m to the power 0, t to the power 0 also here. Simply you will write L to the power 2, it's enough for area. Similarly, second suppose volume. All of you know formula for volume, length into breadth into height. Or you will write the dimension for length, you know length, you notice write L. For breadth, breadth is also a length, L. Height is also a length, distance, so L. So L into L into L, you will write L to the power 3. So dimension of volume is how much here? L to the power 3. Remember this here, volume L into B into H, because length is measured either in meter or centimeter. To meter or centimeter is what here? Unit of length. Breadth is also measured in meter or centimeter length. So always we will use same notation L for each length. Already I have told you any type of the length or any type of the distance, what notation you will write in the dimension only L. Suppose third, suppose density. All of you know the formula density is equal to mass upon volume. And when you will write the dimension of density, so for mass you will write capital M. And already you know for volume, what you will write the dimension for volume? L to the power 3. And in dimension, if any term in the denominator, so that term is transferred in numerator with the proper power. So when you will transfer whole this term in numerator, so here L to the power 3 in numerator becomes L to the power minus 3. So you can write here M L to the power minus 3. It means the dimension of density is M L to the power minus 3. Once again, I would like to remind you here, it not necessary always you will write that t to the power 0. If there is no any term of t, it means it understood here t to the power 0. Like here, no term of m and t, only l is here. It means the power of m is 0 and the power of t is also 0. Next one, velocity or speed. And the dimension for velocity or speed is same. Why? Because their unit is same. You know, velocity is what here? Displacement upon time. Displacement is a length. And you know, speed is equal to distance upon time. So distance is also a length. So when you will write the dimension either for velocity or speed, a dimension formula becomes same. So velocity, displacement time, speed, distance of time. So displacement or distance both is length. So you will write here L, and time as you know upon t. And when you will transfer here this t in numerator, you will write L t to the power minus 1. So this is the dimension of either you say velocity or speed. Next one is here acceleration. Some important dimension I am telling you. Fourth, fifth. Fifth is what here? Acceleration. Acceleration is equal to change in velocity change in velocity upon time. And how can you write the dimensional formula for this one? Change in velocity means, what is the change? Suppose I am saying here 10 meter per second minus 2 meter per second. This one is a change. हाँ, किसी बॉडी की वेलोसिटी मान लीजिए पहले 10 मीटर पर सेकंड थी, अब घट के 2 मीटर पर सेकंड हो जाए तो कितने का चेंज हुआ? तो आप कहेंगे दिस इज इक्वल टू 8 मीटर पर सेकंड। नाउ यू सी हियर इन दिस चेंज यूनिट इज रिमेन सेम, ये नहीं घटता है, ये मीटर पर सेकंड ये था, ये मीटर पर सेकंड था, तो रिजल्ट भी किस में आया? मीटर पर सेकंड। इट मींस चेंज इन वेलोसिटी, its unit or dimension is same as the velocity. So here we can write change in velocity, its dimension lt to the power minus 1, which already have written here. Either you say change in velocity or here velocity, क्योंकि जब change in velocity लेंगे तो उसकी यूनिट नहीं चेंज होगी, और जब यूनिट नहीं चेंज होगी तो उसका डायमेंशन भी चेंज नहीं होगा। तो change in velocity lt to the power minus 1 upon t on time. And when this t will comes in numerator, then 1 t to the power minus 1 again will come here. You will get here L t to the power minus 2. In this way, you can say the dimension of acceleration is L t to the power minus 2. And suppose I hope maybe all of you know force. You know force is equal to mass into acceleration. So how can we write the dimension of this one? Mass m, acceleration L t to the power minus 2. So dimension of this one is m L t to the power minus 2. So some basic dimension better you learn or you can derive with the help of this formula. And time to time when you will use these dimension formula frequently, then automatically it is what here learn. So no need to learn all these dimension formula. If you know the derived formula for any physical quantity, then also you can find out the dimension of that physical quantities. Again, some common formula I want to give you the dimension formula of this one, like work. You know work, it's any formula, you know work is equal to force into displacement. Again, how can we find the dimension of the work? So dimension of work means dimension of force, and already have that dimension of force is m L t to the power minus 2. And displacement is also a length. So what dimension you will write for the displacement? Into L. And now you can write this one is m L into L, L to the power 2, t to the power minus 2. It means the dimension of work is m L to the power 2, t to the power minus 2. Next one, like power. I am giving all these formula means dimension of all these formula because you are familiar with these formula. आप इन सभी फार्मूलों से परिचित हैं, इसलिए इसका easily dimension आप कैसे निकाल सकते हैं. In your book also given there are so many formulas. Maybe the someone is very new for you, someone is new for you, and someone is also old for you. Old for you means someone you know very well about this one here. So work upon time, work already you know, m L square t to the power minus 2 upon t. And you know in this way you can say when you will take this t in numerator, you can write m L square t to the power minus 3. This is the dimension of the power. Linear momentum, all of you know in class 10th and also in the 9th even linear momentum is equal to mass into velocity. Mass into velocity. So dimension of linear momentum you can write for m, capital M, for velocity L t to the power minus 1, and finally the dimension of linear momentum m L t to the power minus 1. So dear students, in this way you can write the dimension formula of the different physical quantity. So today you go through the dimension formula of all these physical quantity which I have given, and also you see there are so many dimension formula of the other quantities also given in your book here. You do the practice for this one, but I am not saying this one to learn all these dimensional formula. the better you learn how can we derive the dimensional formula for the given physical quantity. And in the next video, I will give you what is the application means, what is the uses of this dimensional